Welcome back, students. We'll be looking at section 5.2, terminology for integer exponents and the quotient rule. So let's do a quick review of what we learned in the last section. We learned two exponent rules. We learned the product rule and we learned the power rules. Remember, in the product rule, we actually add our exponents, and in the power rule, we multiply the exponents. Now let's look at some new terminology. A new rule is the zero exponent rule. Any number or variable or symbol raised to the power of 0 equals 1. Always. So anything raised to the power of 0 is just 1. So looking at these examples, 2 to the power of 0 is 1. Negative 2 to the power of 0 would be written like this: negative 1 times 2 to the power of 0. So that would be negative 1 times 1, because that 2 to the power of 0 becomes a positive 1. And then that becomes a negative 1. I wanted to show you the steps written out so you wouldn't get confused. It's still saying any number to the power of 0 is a 1. It's just we have to remember this wasn't in parentheses. So we have that invisible 1 out here being multiplied against that. All right, this next one has the parentheses with the negative inside. So that would become a 1. That negative 2 to the power of 0 is just 1. So that's just to show you the difference between this problem and this problem here and how you would write your answer. The next one has a invisible negative 1 out here. So we have a negative 1 times 2 to the power of 0 is 1, and that equals 1. Let me write that below that here so it's a little bit clearer. And that's our answer. Or excuse me, negative 1. Struggling with this one, because negative 1 times a positive 1 is a negative 1. All right, let's look at the next one. We have 2 times x to the power of 0. This is where we had talked about making sure you understand what is the base of the exponent and what is not the base. The only thing attached to that 0 exponent is that x. The 2 is not. So we end up with 2 times that x to the power of 0 becomes a 1. And we end up with an answer of 2, because 2 times 1 is 2. The next one has 2 times x in parentheses with the power of 0 outside. That changes things. That's different from the one that we just did. This means we have to distribute that power of 0 to everything. So it would be 2 to the power of 0, x to the power of 0. They both would become a 1, so it's 1 times 1, and we end up with 1. Our next problem has 4 to the power of 0 plus 3 to the power of 0. 4 to the power of 0 becomes a 1. The 3 to the power of 0 becomes a 1. And we add those together to get an answer of 2. I would recommend writing these out just like I'm doing, because a lot of times what students will do, they'll go, oh, I know what this means. It means 1. And they forget that there's operations in there that's going to affect your final answer. So make sure you write it out so you can clearly see what you have. The next one has 4 to the power of 0, which is going to become a 1. And then we have minus 3 to the power of 0, which becomes a 1. And 1 minus 1 is 0. The next one has a negative 4 to the power of 0. That becomes a negative 1 times a 1. Remember, because it's not in parentheses, so that's what it looks like. Then we have minus this 3 to the power of 0 becomes a minus 1 times 1. So it's the same situation as that 4. That's going to simplify to negative 1 minus 1, which is the same as saying negative 1 plus a negative 1. If we do a keep, change, change. And that equals negative 2. All right, this next one, I'm gonna draw a little box here so we don't get confused, has a -4 to the power of 0, and that -4 is in the parentheses. So that becomes just a 1. That 3, however, is not in parentheses, so we end up with a minus 1 times 1, like this. We get 1 minus 1, and that equals 0. So I wanted to give you several different scenarios with this so that you could recognize how much the parentheses affects your final answer. All right, so let's look at this new rule. This is the negative to positive exponent rule. So if you have, like this x here, to a negative exponent, what you need to do is transform it to make that exponent positive. And the way we do that is we flip it to its reciprocal, okay? So the reciprocal of this, if I was to turn this into a fraction, would be 1 over x to the positive power of a. So again, the way you make it positive is you flip it to its reciprocal, and that exponent becomes a positive. The only thing is you only do that with the base that is attached to a negative exponent. If there's something else in that problem and it's not attached to that exponent, it's going to stay in the top, okay? Or if it was originally in the bottom, it's going to stay in the bottom. You only flip what is attached to the negative exponent. All right, so let's look at this next one. We have 1 over x to the negative a. Again, that x has a negative exponent, so I'm going to flip it to its reciprocal, and it becomes x to the power of a. It's now positive. What about this next one? We have x to the negative a power over y to the negative b power. Remember I said, if you have a negative exponent, you're going to flip it to its reciprocal. So this becomes y to the positive b over x to the positive a. Our next one has that negative exponent on the outside. There's 2 ways that we could go about this. One way is to distribute it, and we get x to the negative power of a over y to the negative power of a. And then use our rule to flip it. And that would become y to the positive a over x to the positive a. That's one way. Okay, so I'm going to put one way. The other way is if we understand this rule, then we can say, okay, I know that if I flip my fraction, my exponent is going to become positive. So I'm going to rewrite this part just so I can show you the comparison. Okay. If I go ahead and flip my fraction, I can go ahead and make my exponent positive. Then I just distribute, and I end up with y to the power of a over x to the power of a. And we end up with the same answer that we had over here. So again, that's just showing you 2 different ways that you can kind of look at it. And whichever one makes the most sense to you, that's the one you can use. And sometimes, depending on the problem, maybe one way is what we need to do versus the other way. So I want to make sure you know both ways. Let's look at some examples of that. 4 to the power of negative 3. I'm going to put that 4 over a 1, and then I'm going to take the reciprocal, and that's 1 over 4 to the power of 3. Our exponent is now positive, so we're good. Unless the problem wants you to finish doing that 4 to the 3rd power, which you can do that. But as far as getting our exponent positive, we're done. We cannot leave our exponents negative. That's why we have to have this rule. All right, so let's look at the next one. 4y to the power of negative 3. The only thing attached to that negative power is the base of y. So that is the only thing that will move. My 4 is not going to move. It's not attached to it. It's separate. So I'm going to leave my 4 in the numerator. My y to the negative 3 is going to come down to the denominator and become a y to the positive 3. And then we're done. So again, only move what is attached to that exponent. The next one has 1 over 4 to the negative 3rd. Well, we know the rule is to take the reciprocal so that our exponent can become positive. So it would be 4 to the positive power of 3. What about the next one? We have 2 to the negative 4 over 5 to the negative 3. Well, our rule tells us we're going to take the reciprocal. So my 5 is going to move to the numerator, and that 3 is going to become a positive. My 2 is going to go to the denominator, and that 4 is going to become a positive. The next one, I have c to the negative 2, d, a, b to the negative 3. Again, I only move what has the negative exponent. I don't move anything else. So the two items that have that is the c to the negative 2 power and the b to the negative 3 power. The d and the a are not going to move. They're not attached to those. So I'm just going to go ahead and write my d here. That stays. I'm going to write my a here. They don't move. And then I'm going to move my c to the bottom to get my power positive, and my b to the top to get that power positive. And we are done. The next one has 1/4 to the negative 3. Again, there's two different ways that we can do this. I'll show you the first way and then the second way. I can distribute, and it becomes 1 to the negative 3 over 4 to the negative 3, and then flip it, which becomes 4 to the positive 3 over 1 to the positive 3. And that just becomes 4 to the 3rd, because 1 to the power of 3 is just 1. So that's one way. The second way that we could do it is to go ahead and flip our fraction. So we would say 1/4 to the power of negative 3 would become 4 over 1 to the power of positive 3, which is 4 to the power of 3. We end up with the same answer, just using two different methods. The next one, let's go through both process again. That becomes 4 to the negative 3rd over 3 to the negative 3rd. Flip it to our reciprocal. I get 3 to the power of 3 over 4 to the power of 3. I'm going to go ahead and simplify it. 27 over 64. Now let's do the other way. I'm going to go ahead and flip the reciprocal. And I end up with 3 to the 3rd, 4 to the 3rd, which is 27 over 64. So again, we get the same answer. It's just two different routes to get there. And it's not really that either one is any quicker than the other. I would say it's just good to know these in case one makes more sense in a problem than the other one. All right, let's look at our last example of this particular rule. We have 4 to the negative 3rd power minus 2 to the negative 4th power. I'm going to go ahead and flip both of these to get our reciprocals. And I get 1 over 4 to the 3rd power minus 1 over 2 to the 4th power. Before I can subtract these fractions, I need to go ahead and figure out what my bottom number is going to be by simplifying out those exponents. 4 to the 3rd is 4 times 4 is 16, times 4 again is 64. So that becomes 1 over 64 minus 2 to the 4th is 2 times 2 is 4, times 2 is 8, times 2 again is 16. So that becomes 1 over 16. Now I've got a situation where I need to get common denominators before I subtract them. 16 is actually a factor of 64. So I don't have to change 64, but I do need to change the 1 over 16. I'm going to multiply it by 4 over 4, because 16 times 4 gives me 64. I'm going to rewrite that, and that becomes 1 over 64 minus 4 over 64. And I end up with negative 3 over 64. All right, let's look at the quotient exponent rule. We have x to the a over x to the b. Now, when we had the product rule, multiplication, we added our exponents. Now we've got division, which is the opposite of multiplication, right? So we're going to do the opposite. We're going to subtract our exponents. So the rule for this one is x a minus b. So product rule, we add exponents. The quotient or division rule, we subtract exponents. So let's look at this one here. We have x to the a minus, now here's something that's different. We have a negative exponent down here. I need to continue having it as a negative when I bring it up here like this. So make sure you recognize that if you have a negative exponent in your denominator and you're bringing it up to the top to subtract it, you keep that negative. Because what happens is this becomes x a plus b because of that negative there. All right, so let's look at some examples. We have 5 to the 11th over 5 to the 8th. The rule tells me I'm going to take my base, the 5, and then I'm going to subtract my exponents. So I end up with 5 to the 3rd power as my answer. The next one has the base of 3, and our exponents is 7 minus 10. I get 3 to the negative 3rd power. Can't leave it like that because I can't stop with a negative exponent. I need to use my previous rule and flip it to its reciprocal. So 1 over 3 to the 3rd power, it becomes positive. Our next one has 2 negative exponents here. I could go ahead and subtract them to follow this rule. The other thing we know is if we go ahead and flip them, we can go about it that way. But I'm going to show you the first way that I mentioned just so you can see how it results. You'd get the same answer in the end, but I just want to show you. So we get 2 to the negative 5 power minus that negative 3 power. Remember, we have to show both the minus sign and the negative that came with that 3. That becomes 2 to the negative 5 plus 3. With that, keep it, change. That's going to come down over here. And we get 2 to the negative 2 power. Can't leave it like that. I've got to switch it. So it becomes 1 over 2 squared. And now we're done with that one. Let me show you, if we had used the previous rule to go ahead and get our exponents positive, how that would have changed things, but we still would have ended up with the same answer. I'm going to do it in a different color. So it would have become 2 to the positive 3 over 2 to the positive 5. I would say 2 to the 3 minus 5. That gives me 2 to the negative 2, and then I have to flip it to get 1 over 2 squared so that my exponent is positive. We still ended up with the same answer. It's just 2 different ways to go about it. And that's one of the cool things about knowing all these rules is sometimes, depending on the problem, one rule may work better than another, even though both of them are possibilities of being used. Let's look at the next one. A to the 3rd, m to the 9th. 8 to the 5th, m to the 10th. Okay, so we've got 2 different bases going on here. We have 8s and we have m's, and we need to keep them together as far as their exponents being subtracted. So I'm going to say 8 to 3 minus 5, m to 9 minus 10. That's going to give me 8 to the negative 2, m to the negative 1. We ended up with 2 negative exponents, so we need to flip that. Both of them are going to move because both of them have that negative exponent. And we end up with 1 over 8 squared m. All right, the next one has x plus y in parentheses with a negative exponent. The next, and the one under that has x plus y also with a negative exponent. I think the simplest thing to start out with is to flip it and get our positive exponents first. So let's see here. I'm going to say x plus y to the positive 4th power, and then x plus y to the positive 3 power. Now, because those exponents are attached to everything in that parentheses, I can and everything in the parentheses is the same as each other, I can go ahead and set it up like this. X plus y to the power of 4 minus 3. That's only because our base was the same. Both of them had the base of x plus y. If they were different, we wouldn't be able to do this. So now I can say that becomes x plus y to the power of 1, because 4 minus 3 is 1, which is just x plus y. We don't actually have to write that 1. Now, you could have gone the other route and go ahead and subtract the exponents. You would still end up with the same answer. So let's show you that. So if I go ahead and say, let's see, let me rewrite it out here. Oops. Let's go ahead and write it out as the rule says, x plus y, -3 minus -4. I end up with x plus y, and then I have a -3. I'm going to do keep, change. So -3 plus 4, and I end up with x plus y. -3 plus 4 is a positive 1, which is just x plus y. So again, it just shows you that depending on which route makes the most sense to you, both routes get you to the same answer. Last example for this particular area, we have 7x to the -3 y squared over 2 to the -1 x squared y to the -5th. All right, we've got a couple of things going on. I have this negative power, I have this negative power, and I have this negative power. So what I'm going to do is I'm going to go ahead and just switch them to their proper location so that we know where they are. I think, let's see, is that what I want to do first? Yeah, no, let's go this route. I think this will be the easiest route to not get confused. I'm going to say my 7 is still here. My x is the -3 minus 2. My y is the 2 minus the -5. And then I needed to bring up my 2 to the power of 1, so it's right here because it had a negative power. Now let's simplify these out. 7 times 2 is 14. And then I have my x to the -3 minus 2, which is -5. I have y to the 2 minus -5, and that actually becomes 2 plus 5. So I get a positive 7 here, and I've already dealt with my 2. Now I have that x to that negative power, so I need to move it. The 14 stays in the numerator, and the y stays in the numerator because they're both positive. But that x is going to move to the bottom so that its exponent can become positive. And that is our answer. And here again, there's so many pieces there. That's why I really impress upon you to write out your steps. Let's look at some mixed rules examples. We have 3 to the power of 4 squared over 3 cubed. All right, so the first thing I need to do is deal with the power raised to the power. So that's going to become 3 to the 4 times 2, because we're using our power rule where we multiply, over 3 cubed. That's going to become 3 to the power of 8 over 3 cubed. Now notice I didn't solve out my 3 cubed yet. I didn't turn it into what that actually is, which is 27, because I need to wait on that. I may be able to cancel out some of those before I do that. And that's what's going to happen here. I end up with 3 8 minus 3 up here because I have that quotient rule that I need to use. And then that becomes 3 to the power of 5. If I had already done that 3 to the power of 3 and turned it into a 27, I never would have been able to do this part here. The next one has x to the negative 2 times x to the negative 1 times x to the 4. The temptation with these is to go ahead and switch our x's with the negative exponents and into the reciprocals. But we don't want to do that yet because we may end up with positive exponents once we combine them with that 4. So let's do that first. Let's use our negative exponent, or not our negative exponent rule. Let's use our product rule first. So we have x negative 2 plus that negative 1 plus that 4. So I have x to the power of negative 2 plus negative 1 is negative 3. And then I still have that plus 4 there. And we end up with x to the power of a positive 1, which is just x. That's why I don't want to flip until I absolutely have to, because sometimes when you use another rule, you end up with a positive number. You'd end up not having to flip at all. Let's look at the next one. 4m to the power of 5 times 4m to the power of negative 3. Our bases are the same. So I'm going to use the product rule here and say 4m to the power of 5 plus that negative 3. The product rule says we add them. And that becomes 4m to the power of 2. Now I can distribute that 2 to everything, and I get 4 to the power of 2, m to the power of 2. 4 to the power of 2 is 16, and then m squared. And we're done with that one. So again, this just emphasizes how important it is first to know your rules, understand what they do, and then to write down your steps so that you can keep track of everything and see how things have changed. The next one has a fraction to a negative power. I'm going to use the rule that tells me I can actually flip this and make that power positive. So I get 5 over, or excuse me, I forgot to flip it. So 2r to the power of 4 over 5. And all of that is now to the positive power of 3. Now I can distribute that out. So I get 2 to the power of 3, r to the power of 4 times 3, because this is not multiplication rule, our power rule. And then we have over 5 to the power of 3. All right, I'm going to simplify that out. 2 to the power of 3 is, let's see, 2 times 2 is 4, times 2 is 8. And then we have r to the power of 12. 5 to the power of 3 is 125. And we are done with that one. The next one also has a negative exponent. So I'm going to go ahead and flip my fraction again. Now pay really close attention to what I do here. I put my 7 up here and I keep it to a negative 1. The reason is because our flipping is not fixing that part. It's only fixing the negative exponent on the outside of the parentheses. So make sure you don't change those, okay? Just what's outside the parentheses becomes positive. So I end up with 6y to the negative 4 here. And then this becomes a positive 2. Now I'm going to distribute it throughout. We say 7 to the negative 1 times 2. And then x to the 5 times 2 over 6 to the power of 2, y to the negative 4 times 2. Go ahead and simplify that. We get 7, negative 2, x, 10. 6 squared is 36. And then y to the negative 8. Now we've got some negative exponents that we need to work with. So let's see here. We're going to move the 7 to the negative 2 power. So I get x 10 here. My y to the negative 8 comes up. And then down here, I have 7 to the positive 2 power times 36. And no variables, because both of my variables moved up. Now I have, or no, that's not a negative 8 on my y, that's a positive 8. Sorry, guys. There's a lot to keep track of here, and I want to make sure I don't make any errors for you. Okay, so my 7 squared, so I'm going to rewrite the top. That 7 squared becomes 49 times 36. And so we end up with x to the 10th, y to the 8th over 1,764. Now I want to show you a different way that we could have gone about this, but I need to write the problem down. So let's just put this here. And I have, let's see, 6y to the negative 4 over 7 to the negative 1, x to the 5th, and that's to the negative 2 power. All right. I want to show you this because this might actually be an easier way. We'll just test it and see. Let's go ahead and distribute that negative exponent. Maybe it'll turn some of our negative exponents positive and we won't have to move them. So I end up with 6 to the negative 2 power. Y becomes negative 4 times negative 2. And then all of that is over that 7 to the negative 1 times that negative 2. And I get x to the 5th times negative 2. The 6 to the negative 2, I can't simplify. I've got to move it down to the bottom. So it's going to come down here and become to the positive 2 power. My y becomes, negative 4 times negative 2 becomes a positive 8. My 7 that's down here, I have a negative 1 times a negative 2. So that becomes a 7 to the positive 2. My x has a 5 times a negative 2. That becomes x to the negative 10. So that needs to move up. So I end up with x to the positive 10 here, y to the positive 8. 6 squared is 36. 7 squared is 49. And I end up with the exact same answer. So this way might be slightly easier just for this particular problem. But again, I wanted to show you both ways so you could see that you have some options depending on the problem, which route you want to go. All right, last example, we have 6c to the negative 1, 3c squared to the negative 2. I'm going to go ahead and flip. So I'm going to rewrite 6c. Oh, I keep doing that. I keep forgetting that I'm flipping my equation here. I get 3c squared up here to the power of 2. And then in the bottom, I get 6c to the power of 1. My exponents became positive. All right, so now let's go ahead and distribute. I get 3 squared c to the power of 2 times 2 over 6, 1, c1. Simplify that, and I get 3 to the power of 3 to the power of 2 is 9. C becomes c to the 4th. 6 here and c here. We don't have to write those ones. The 6 is not going to move, but I do need to combine my c's. So I get 9c to the 4 minus 1 over 6. And that becomes 9 over 6c to the 3rd. I can reduce my fraction. I'm going to bring my answer over here by 3. And so I get 3 halves c to the 3rd. And that is my answer for that particular problem. All right, let's look at our Bible verse. He has told you, O man, what is good, and what does the Lord require of you, but to do justice and to love kindness and to walk humbly with your God. Micah 6:8. All right, guys, I'll see you in the next video. Hope you're having a great week. Bye.